Thank you.
So we thank Professor Moropouli for the introduction, and I think we can now start with Professor Ioanna Papagianni.
I'm here.
Yes.
I'm going to present the work of Noni. Noni
okay.
sent a presentation.
That's a surprise.
So,
okay.
Although she's not here.
So we start with the presentation of Noni.
Because
okay.
she was the moderator, so she had already worked.
Okay.
And,
you can do it on her behalf. Okay.
I will present it on her behalf.
Okay.
Probably it's better to go here, so I have the control.
Maybe you need to switch on your microphone. Το πράσινο κουμπί.
Yes. Okay. Is that okay? Yes. Okay. So the panel has already been presented by Professor Moropoulou, trying to make a certain presentation of the matters that we are going to discuss today. Okay, thank you. First of all, let's remind that, as we all know, built heritage protection involves a combination of disciplines. That is why this panel has such a lot of disciplines, as well as basic knowledge of scientific and technological aspects, but I would as well add historical and other aspects regarding the aesthetics, the arts, as well as understanding scientific, technological, cultural, social, and values. And these values are conflicting ones. So, as we are going to see, we need a kind of optimization at the end. The other point is that we must always think of the building as entities. We must think the integrity of the building, not only the materials or some parts of it. Of course, there is a relationship between physical deterioration and the environment, and that integrates art, materials, and structures, and there is a need of understanding the evolution of historic structural systems and contemporary methods. Speaking about principles, of course, I'm not going now to present the whole Charter of Athens and Venice and its evolution, but one has to point out the importance of compatibility, which concerns not only the materials with the existing ones, but as well the structure itself, and has a lot of parameters, and the reverse engineering to performative materials. So we learn from what we find, and then we're going to design materials and interventions that they are compatible. Of course, we need to evaluate the restoration materials, compatibility, but not only compatibility, but as well as their durability and longevity. Another point that it is very much discussed in our work, it is the principle of reversibility that it was used very much in the past. Now, after many years, the tendency is that this term, it is completed by another term, which is retreatability. This means that when an intervention or material it's not possible to be reversible, then it has to be compatible in such a way that it will permit for the future generations to retreat the surface or retreat the structure. Reinterventionality, as Professor Tasio says. And then here I will add something, it is not written by Noni, that in the ISCAR Committee of ICOMOS regarding more the structural restoration of monuments, we propose now, instead of reversibility, to use the word removability, because in the reality, nothing is really reversible. When we intervene, we are doing a certain harm, small or big one. So probably removable, it's much more close to the reality. Of course, another point is the monitoring of the decay state and of cultural heritage and the assessment of the effectiveness of the intervention. So we must not only apply interventions as materials, but we must judge them in the future and try to understand if finally they were good or not. And of course, the preventive conservation, this is something very, very important in order to avoid important damage. Of course, there is an open discussion about the cultural materials in the climate change, we all know. I will not go through all the points that Professor Maravelaki has noted. We all know that we need to take this matter into account. We need to make some specific studies in the various sites, because they are not the same. The situation with climate change in Peloponnese or the North Greece or in other countries has differences, and that is why it is very important to have data, and on basis of this monitoring system data, try to make some workshops and training, and make not only the professionals, but as well as the public, to make them aware of this problem, which is as well a real problem for the monuments. I'm sorry, the next one it is. Of course, there is as well the question of artificial intelligence. There was a session this morning. This is something that concerns as well the restoration and conservation of monuments, because a lot of help can be given by this approach regarding image recognition, pattern detection. It may assist experts in preserving sensitive artworks and archaeological items. It also contributes to the protection of cultural heritage sites by addressing physical effects through environmental monitoring. Thanks to artificial intelligence, necessary precautions can be taken before existing or potential risk damage the heritage. So we need as well to think about rational use of artificial intelligence by balancing technological innovation with ethical concerns. Cultural heritage can be preserved in a sustainable and inclusive way for future generations. Now, we are in a period that sustainability is very, very important. So when we intervene in the monuments, both regarding materials and intervention, we must think about circular economy, the resource management, try to use the the necessary material, not overdoing, not waste sources. Try to think about the life cycle of analysis, try to reuse the materials, and of course adapt them to the climate. In the future work, of course, we have some proposals from Noni Maravelaki, integrating new artificial intelligence systems developed in research projects into existing systems, publicly sharing and generalizing models trained on cultural heritage collections, implementing artificial intelligence in a way that is considerate of ethical, legal, and social aspects, reducing the carbon footprint of training models and processing at scale. I would like to add here in these proposals of Noni that we have as well to try to prepare in a way that will reach all the professionals the knowledge we already gained. So we need some regulatory documents, both regarding materials, because we know a lot of things, and regarding as well the structures. And finally, as we embark on this transformative journey, it is crucial to continue fostering interdisciplinary collaborations and community engagement to ensure the effective and responsible preservation of our shared cultural heritage. Thank you.
Thank you very much, and also for adding some clarifications. we will need now to continue with Professor Ioanna Papagianni from Aristotle University of Thessaloniki.
Here, yeah.
Will you speak from here? Or? Okay.
I wait for the screen.
Okay. But who changes the slides?
Yeah. No, oh, I have seen. Yeah, here. Thank you for the opportunity. I must thank you, Professor Meropoulou, for ask all of us to be together and discuss very top topics, I think, such as sustainability and economy aspects, repairing cultural heritage or historic structures with lime-based materials. Oh, how to...
Δεν ξέρω. Ωραία. Το βέλος.
Okay. I have some experience working with postgraduate students. I have also some opinions about how to use artificial intelligence in designing, for example, compatible repair mortars. So I would like to share with you these opinions. My opinion is that the last 30, 40 years, it seems that particularly in the case of monumental structures, as we say, all the principles of restoration, compatibility, materiality, architecture in general, are taken seriously into account for designing new repair materials, and especially lime-based mortars dominate in repair works of historic structures. As far as I know, communicating with the most important laboratories in Europe, and not only. Of course, in the case of rehabilitation of historic buildings from the end of 19th century, beginning of 20th century, this compatibility and materiality are not always kept. I can confess that I have seen owners of historic buildings to insist on using cement because there was moisture in masonry, traditional masonry of the structure. In addition, it was not something that happened without work previously. In the last decade of the 20th century, great projects funded by European Community were implemented. And in addition, in the frame of consecutive RILEM technical committees, many things have been clarified as the meanings of compatibility in technical terms, how to achieve compatibility, for example. And also a step forward was to modify existing standards or propose new ones in order to be more adaptable to lime-based mortars. Nowadays, apart from compatibility, it's very important because of climatic change. It's very important to have long-lasting repair materials. It's another parameter. So are pursued these long-lasting repair materials, not only for economic reasons, but because if you have no interventions, you have economy, of course, and because of sustainability, as we say, aspects. To enhance a little these options is the fact, according to European reports, Eurostat, that restoration of monuments, including also the rehabilitation of old building stock in urban areas of Europe, historic centers, we say, is considered around 35% of the construction market. It's something that is important. And of course, economic issues we know very well. Tourism, for example, are closely related to repaired historic centers. But if they continue to be historic centers, means authenticity, materiality, and architecture have been safeguarded. We have now ways to benchmarking alternative sustainable solutions for selecting raw materials. We have life cycle assessment, different scenarios, cradle to gate, from materials extraction up to factory gate, cradle to grave, up to the end of life, including recycling many times. We have EPDs, which are certifications about the carbon trace of the constituents. We have also, in the case of cultural heritages, we have life cycle analysis, including the impact to economy, and SLCA, life cycle analysis, considering the impact to society. In the case of monumental structure, cultural heritage in general, all tools should be used together in order to have a realistic estimation of sustainability. By using the tools I mentioned previously, we proved easily that a repair solution based on lime is not only compatible, but is also environmentally friendly. Is about the half of comparing the carbon dioxide emissions if we use cement and if we use lime-based mortars. In the case of lime, of course, we have recapture of carbon, 33%, according to a report of Polytechnico of Milan in 2020. Furthermore, research progressed to produce now lime based on a biomimetic approach of recycling waste, or we can use additives in lime-based mortars that enhance capture capability of carbon dioxide or improve what we say functionality, photocatalytic functionality, for example, of plasters or of renders. A great challenge for me, the future challenge, is designing lime-based mortars by using artificial intelligence. Of course, it's undisputable. Yes, we can say that we are sure that all artificial intelligence processes data faster than human brain. And we, as a human brain, decide on reliable data, on our empathy, on experience from damages, on social background, inspiration. We're not always based on data. So I say to my students, whenever we are in front of a decision taken by artificial intelligence, we must ask, which is the platform the data come from, which is the model and the assumptions of it. We take the same decision without artificial intelligence, and we must know very well the consequences of an unsuitable or wrong decision. Because artificial intelligence is not to substitute our critical ability, but to enhance it by enriching our experience. Thank you. To keep the time.
Thank you very much for also being very precise with time. And we move on with Professor Παναγιώτης Σπαθής. Θέλετε να πάτε από εκεί?
Εδώ.
Ναι.
Το ποντίκι.
Αυτό είναι για
Δεν
το
ποντίκι, αλλά...
βέλος μόνο. Μπρος πίσω.
Okay. Good afternoon. Thank you to Professor Moropoulou to invite me to be here in this very, very important conference. Okay, thank you. Discussing about in the general field of preserving compatibility, materiality, integrity of structures, architectural authenticity. We will discuss for a little about the role of advanced nanocomposite coatings with semiconductive, hydrophobic, superhydrophobic properties for preserving materials integrity and transmissibility. Okay, thank you. Preserving compatibility, material integrity and authenticity is about balancing old and new, respecting history while allowing structures to evolve. Successful conservation protects cultural identity while ensuring buildings remain functional for future generations. So we will discuss about protective coatings, which are the desired properties, general of protective coatings. Protective coatings must produce hydrophobicity, breathing of the substrate, resistance to environmental factors, preservation of protective properties, no alteration of the optical properties of the stone, the application of the coating should be a reversible process, and compatibility. Starting with polymeric coatings. Disadvantage of polymeric coatings. Sensitivity to biodegradation, photooxidation action UV, low compatibility, change of appearance, color change of material, limitation of water vapor permeability, hydrophilic, hydrophobic interface, water condensation, development of mechanical stresses. No inhibition of the diffusion of calcium ions from the surface of the stone to the corrosive environment, structural changes, irreversibility of the process, shorter lifespan, no long-term preservation, final acceleration of wear and tear. And now, we go on with durability and physicochemical stability. Polymers. Extraordinary performance as freshly applied, but very risky in the short and medium term. Thus, the chemical nature of the substrate, the work of art, should be the driving factor in selecting and formulating new materials. Art-compatible materials need to match the properties of the materials constituting the works of art. Other materials and techniques have been developed. An important, not the only one, but a critical key point for all this development of methods and materials is the well-known Florence fluid in '66. And also a second one point, material science, colloid science, nanoscience play a fundamental role for the development of new art-compatible materials. Now we continue after polymeric materials to various other methods for the protection of building materials of monuments and works of art. Method of protection with N semiconductors. It is well known the catalytic properties of semiconductors and what we have done is to produce protective coatings as we edit N semiconductors to N reaction of oxidation, that means corrosion, and so we have a reaction retardation. Here I have to say that we cannot discuss about cultural heritage and conservation of monuments without a reference to the work of our teacher, Professor Skoulikidis, who has a very important work on all these fields. Adding semiconductors to polymers means that we prepare oxides, hydroxides of various elements with N semiconductor properties, and so we have with polypolymer sulfurization and cracking acceleration, doped polymers we have protection, increased protection with increased semiconductivity, protection, and from acid rain. Second method, hydrophobic protective coatings. A water repellent layer on the surface of the building material exerts an important protective effect as it does not allow water to penetrate the pores or cracks and cause damage. Unsolved problem, a surface layer is suitable for the protection of low pore material but not for high porous ones, because if water accesses the pore system from some unprotected surface or an internal source leaks capillarized by soil moisture, condensation of moisture under the coating will not play a protective role. And second, the durability. All hydrophobic materials undergo oxidation when exposed to oxygen and light and lose their water repellency over a period of time that is still very short, about 5 years for the best materials, until now. Here we see some experimental results of our laboratory from various bulbs, Thasos and Dionysos, and with various protective coatings, polymeric alkoxysilans with nanocomposite, hydrophilic and hydrophobic. And also we have a work about super amphifolic composite coating for the protection of marble natural. Stone made in our laboratory. We have enough time to see all of this. Polysiloxane material, hybrid material, superhydrophobicity, solophicity, superamphibicity was presented in previous conference here. Also in organic nanomaterials for the consolidation of wall paintings and stone, the well-known Ferroni method, the millstone of pioneer use of compatible consolidated orthotics, calcium hydroxide, the first nanomaterial used in restoration. Factors affect the performance of nanoparticles. And organic and inorganic hybrid nanocomposite. Typical features of nanocomposite: mechanical projected, resistance, chemical resistance, decreased permeability, protection against ultraviolet radiation. The organic part usually provides hydrophobic adhesive properties to the film. The inorganic portion grants a higher physiochemical compatibility with carbonated silicate stones and provides consolidating or protective properties. Here, various kinds of nanocomposites tested user prepped coatings in metals, marbles, or stone. Inorganic nanomaterials for certification of paper, also. Stable dispersion of calcium hydroxide or magnesium hydroxide nanoparticles for the desertification of paper. and also inorganic nanomaterials for the desertification of waterlogged wood, an application for the consolidation treatments with silicon-based materials, solid techniques, and also work made in our laboratory. This work will be presented this afternoon here, one collaborator of our laboratory, highly hydrophobic siloxane nanoglycerine hybrid coating for the protection of heritage wood. So, we have that. Same polymeric materials, we have acceleration of corrosion, sulfurization, fracture, and after we have the methods materials with niche semiconductors, reinforced polymer materials, inorganic nanomaterials, hydrophobic materials, hybrid nanocomposite materials, and what else in the future. And we have enhancements of mechanical anti-corrosion and antioxidant properties. And closing, working to prepare a new generation of researchers on the fields of preservation of killer heritage. We have organized, there is more than 10 years, and we continue a transnational master course program. We have every year about 25 students, selected from about 200 applications from many countries from all the world. And this archaeological materials program is an integrated master program, University of Évora, University of Thessaloniki, and Siapessa Rome University, and with many other associated members and partners from all Europe and not only. Thank you very much. I was out of time.
You were a bit out of time, but very inclusive.
Thank you.
I think we can now move with Professor Athina Georgia Alexopoulou. Thank you.
Okay, thank you. Good afternoon, everyone. It's truly an honor to stand here among such esteemed colleagues, united by our shared effort, the preservation of our architectural heritage, and in general, our cultural heritage. We do not speak only about safeguarding structures. We are talking about the tangible stories of humanity, the very fabric of our cultural identity. But this task, as we all know, is fraught with challenges. From our hand is the environmental degradation, the non-stop march of time, and the demands of modern use that constantly test the integrity of these irreplaceable treasures. From the other hand is the imperative need for adapting green and sustainable solutions. True eco-responsible practice demands a transformation in how we approach all aspects of cultural heritage work, from research and collection to diagnosis, conservation, restoration, interpretation, exhibition, and transmission. These processes must prioritize ecological soundness, accessibility, sustainability, and inclusivity, moving away from resource-intensive, environmentally damaging and unsustainable methodologies. Initiatives like the MOXIE, Go Green, and Green Art projects funded by the EU Horizon 2021 program are actively addressing these challenges by proposing green and sustainable materials and methods for cultural heritage preservation. I'm happy to be part of this effort. We are happy to be part of this effort, coordinating the University of West Attica team for Green Art Project, which is dedicated to developing cutting-edge, eco-friendly solutions for both curative and preventive conservation of cultural heritage. Aligned with the European Green Deal, a key focus of green art research is replacing traditional conservation materials such as polymers, solvents, and surfactants with biological, natural, or low-impact materials that are fully sustainable. And I have to say that is the first time that all these materials are produced and are being approached by all the stage of production. That means production, evaluation, test in real materials, and studies about safe cycle assessment and life cost assessment too. These solutions includes developing new consolidants, coatings, and packaging made from plant proteins and polysaccharides sourced from renewable resources. By bringing together academic institutions, you see now the categories of new green material here. By bringing together academic institutions, innovative industries, small and medium enterprises, museums, public entities, and policy makers, green art fosters an interdisciplinary approach to protecting and restoring invaluable cultural treasures. Green art champions non-destructive testing, NDT, particularly imaging techniques, to undergo rigorous assessment and elevation of these novel green materials, and this is where we come. Non-destructive testing is a leading approach to diagnosing the condition of movable and immovable cultural heritage. We've built years of expertise in this field, and we believe for good reason. NDT offers a range of benefits. It's a green technology, eliminating the need for sampling. It allows for in situ application, providing immediate results, and it's both user and environmentally friendly, minimizing waste and energy consumption. Furthermore, advancements in imaging technology enable the capture and analysis of even minute details, making it a powerful tool applicable to a wide variety of artifacts and structure, from stone, metals, and frescoes to paintings, ceramics, and archival materials. This versatility supports a multidisciplinary approach to documenting, analyzing, and protecting works of art and structures, offering substantial added value. By NDT, performing serial checks, monitoring the evolution of deterioration over time, and assess the long-term effects of environmental factors or conservation treatments is also possible. Ultimately, NDT provides a green, fast, reliable, economical, and safe method for testing, especially crucial when dealing with delicate or high-risk objects and structures. But NDT isn't perfect. A main difficulty is that we primarily get qualitative results, and interpreting and quantifying images requires expertise. However, technology is rapidly evolving. The progress in the information technology, image processing, artificial intelligence have boosted their interpretation, bridging the gap, making NDT much more attractive. Let's say very much attractive. Thus, despite the learning curve, with the right training and understanding, NDT offers an unparalleled level of insight and control in the documentation restoration process, as we have the chance to find it from the excellent presentations in this symposium. Speaking about Green Art project implemented in the framework of the Horizon 2021, I was to emphasize the importance of Greece's participation in the proposed European Partnership for Resilient Cultural Heritage under Horizon Europe. This initiative is a co-funded European partnership between national, regional research and innovation funding agencies, governmental organizations, ministries, social partners, and employment, education, research, and innovation institutions. It aims to strengthen the preservation of Europe's cultural heritage, contribute to climate neutrality, and foster innovation through interdisciplinary research, which is in the core of modern scientific work. However, Greece's participation is not guaranteed while funding opportunities are limited to participating countries. Greece, with its invaluable cultural heritage, faces severe impacts from climate change. There is a special panel on this issue within this conference showing the importance of this matter. Participating in this international partnership would provide Greece with the opportunity to collaborate with other regions and organizations developing and implementing innovative solutions, models, and strategies to protect and preserve our cultural heritage in the context of the United Nations Sustainable Development Goals and EU policies on green and digital transition, societal inclusion, and resilience. We urge the Greek authorities to address this issue and support Greece's strong involvement in the European Partnership for Resilient Cultural Heritage. We, the academic, scientific, and cultural heritage communities, as well as Greek society, expect decision-making centers to support our efforts toward a sustainable and resilient cultural heritage. Thank you.
So it's my time now. Someone has to stop me. Πατσαβός. Okay. So I will briefly talk about how the specific issues related to the management of modernist architectural heritage may be relating or may be related to the topic of this table. So modern architecture, despite its historical significance, faces unique preservation challenges. Concepts such as the ones that have already been explained and discussed, like compatibility, materiality, and integrity, become complex when dealing with modern materials, modern in the historical sense of the 1930s, yeah? And construction methods. Texts like the Venice Charter of 1964 were not designed for modernist heritage, raising the question, should our international conservation ethics evolve in some way in order to be able to adapt to the need of preserving and reusing these monuments also? Of course, there is a paradox referring to something which is modern and it is a monument. There are some key challenges that we may point out. The first one would have to do with materiality and structural integrity. Modern materials such as reinforced concrete, early plastics, experimental architectural finishes degrade differently and require interventions that challenge authenticity. They have to be replaced most of the times. Compatibility and sustainability. Many modern buildings were not designed for longevity, they were not monumental in their intention, and they were not energy efficient according to the way we define this today. So how do we balance preservation with the need for sustainable performance? And the idea of adaptive reuse, highlighted by DOCOMOMO, the international body focusing on documenting and protecting modernist architecture, which was deeply function-oriented from its conception. Unlike monuments of the past, its very essence is tied to the idea of function and adaptability. Sustainable management must focus not only on material conservation, but also on ensuring that these structures continue to serve a purpose in contemporary society. I will very briefly present some case studies which I think provide us with an array of the issues we have to deal with. The first one is the Bauhaus building in Dessau, Germany. Originally, of course, designed by Walter Gropius, constructed between 25 and 26. And the background of the story, we all know, it has to do with the Bauhaus school moving to Dessau in 1925, where this iconic building was constructed by Gropius as an expression of functional modernist principles. The restoration efforts related to this have to do with the first one in 1976-79 during the GDR times, which was not fully faithful to the original design. The 1996-2006, which were a very comprehensive restoration by Wilfried Brenne Architekten Office, restoring original materials while improving long-term preservation. And the 2017 Bauhaus Dessau Conservation Management Plan for the systematic and long-term conservation and management of the Bauhaus building in Dessau, which is more or less a set of principles and guidelines, both regarding everyday function and use of the building and future possibilities related to its use, with the support of the Getty Foundation. So should we prioritize original materials or long-term sustainability when preserving modern structure? That was a question which was put by the Bauhaus example. Now, the second case study is the Tate Modern, as it is called now, in London, originally designed by Sir Gilbert Scott, which was the architect of the Bankside Power Station, which was not needed as a power station anymore. And it got decommissioned for that reason and transformed later on in the early 2000s, in a way, into a new department of the Tate Museum, which was focusing on modern art and contemporary art. Now, its first conversion into art museum was done by Herzog and de Meuron from Switzerland, maintaining the industrial character while introducing public and exhibition spaces and with an architectural concept which was meant to enhance the kind of function of the building as an interior public square and to connect it with the adjacent public space. The same office, the same architects in 2016 completed the expansion, the addition of the Blavatnik building, a twisting brick parametric addition by which was expanding the museum's capacity, which the museum had become very famous since its original opening, while maintaining architectural harmony in the way that the new and the old wings relate to each other. One of the lessons related to that is, can adaptive reuse preserve both the historical and functional essence of industrial heritage? The third example is the Torre Velasca in Milan, which is the way we were being taught about that was it was a prestigious postmodernist building. Actually, it's not a modernist one. Originally designed by Studio BBPR and constructed in 56-58. A post-war architectural landmark of the city, blending modernist principles with references to medieval Italian architecture and in a way reconciling the modernist tower and the way it works. Its current adaptation by Asti Architetti under Paolo Asti is restoring the building while updating its use, and one of the issues related to it is adaptive reviews as a way to ensure economic viability while preserving cultural integrity. From the local context of Greece, of course, the Xenia Hotels program of the 1950s and 60s, directed by Aris Konstantinidis, many of the hotels designed by him. It was a network of modernist hotels designed to promote tourism and to relate it with nature and culture, ancient culture mostly, in post-war Greece as a development tool of the country. Most of them have been abandoned, some repurposed, and a few restored, usually not very well. The challenges are many. For example, the conflict between preservation and modern hospitality industry demands. The risk of over-altering the building to meet commercial pressures is eminent. Instead of proposing incompatible 5-star hotel standards and trying to fit them to this building, to each one of these buildings, maybe we should create a new heritage hotel model that maintains not only architectural integrity, but also the historical concept of that period hospitality, including original services and comfort levels of the times. There is an example of that with the TWA terminal in New York, which has been turned into a TWA hotel of the 60s, the Saarinen building. Okay, that's a Xenia owned by used by our university. There is a special issue which colleagues here are more related to it, which is the seismic adaptation challenge of these buildings. They were designed using mid-century structural techniques and models that don't comply with today's codes. Possible methods is fiber-reinforced polymers, base isolation or damping systems, custom retrofitting strategies, which of course are raising also a lot of cost considerations, raising the question, should we view these expenses as a burden or as a kind of investment that we can calculate in the long-term cultural, social, and economic value of these monuments? And moving to the last example, the Venice Charter, which does not fully address modern challenges, we may propose some updates recognizing adaptive reuse as a valid conservation strategy, expanding the definition of authenticity beyond materials to include social, economic, and environmental sustainability, developing guidelines for balancing heritage values with contemporary needs and cultural values. Modern architectural heritage is fragile yet vital. Most modernist buildings were both experimental and non-monumental. We need a revised, if not innovative, toolkit of concepts, methods, and techniques. Balancing authenticity with functionality and sustainability is crucial. Sustainable management of modern architecture must focus primarily on the new function and the original function of the buildings, because maybe, in a way, trying to preserve their architectural essence would need also to have some kind of new function, which is a reinterpretation of the original one, because this was central in the concept of the building. In a way, if you spare its functions, there is no building left. Updating international guidelines is necessary, and we need to acknowledge especially the role of social, economic, and environmental sustainability. We need to invest a lot on public awareness and acceptance, because there is a serious lack on that level regarding modernist heritage. Their historical and aesthetic, if not any other values, are not easily recognizable by the public. Modern heritage, of course, still a paradox, or maybe just in transition. The decisions we make today will shape whether these buildings survive as a testament to modernism's ideals and achievements or fade into obscurity. Thank you. And now we move with Professor Kostas Karadimas from the Polytechnion.
Okay, thank you, Professor Patsavos. I'm gonna say it by heart. I'm not going to read as if I'm making a lecture to the university, say. So our issue is the importance of documenting structural system in presenting architectural identity. If we think and discuss about, the structural system or the structural framework, say, of a building, in most cases, even going back to historic terms, the structural framework, it's the building itself. So a short building has a short structural framework, a tall building has a tall structural framework. There are issues of either decorative features or many other things that are actually added to the surface of the structural framework, or even wall materials that are actually composing the building itself. So in one term, by preserving the structural framework of the building, you are preserving the building itself. And by securing the fact that the building is going to live in many years, you are in one way or another securing the fact that you are preserving the structural framework of the building. In most cases, and especially in old times where there was not such a need of mainly the standard building of having most decorative fixtures or more, added things on top of the framework, the building itself was standing in terms of the framework itself. So the documentation of that part of the building is quite easy. It's you measure, you document the structural framework itself, so you're actually documenting the building. There is another issue that I want to raise, and this is the main point that I'm gonna, figure out. There are many things that are associated with the structural framework of the building, especially in this part of the world that we have earthquakes, that are in one way or another hidden. So there are things of the framework itself, not the main framework, but the additive parts that are in one way or another they are incorporated in the building, they are hidden. So the need of documenting these parts that are in one way or another hidden is more important, because there are many cases either we lose them or we hide them again. From that point of view, I'm going to say, for example, the standard thing of, wooden ties. The wooden ties that are going all over the buildings that are usually focusing either to the seal or the base of an opening or the beginning of a floor have certain, there are certain cases where you have some additional frames, say in the openings, wooden parts that are associated in the opening itself, which in one way or another are hidden in the structural framework or are hidden in the plaster. If you are going to restore the building and you are going to represent and redo a kind of plastering, either you hide them or you lose them. So the thing that the importance of, documenting and importance of reconstructing in one way or another with all types of, all types of weapons and all types of materials that we have now is in one way or another of great importance from that point of view. Another thing is is of some importance equal to that is the fact that the structural framework itself is not just one piece. There are many pieces that are connected together. So the joint, which is actually an interruption of the continuity of the element itself, gives another most important thing that has to be documented, because in one sense or another, this is most vulnerable in any kinds of, we are going to lose it in easier works, or it's something which is going to corrupt or deteriorate in a more easy way than the material itself. So it's not the element, it's not only the structural framework, but it's actually the hidden parts that are of some importance, and the structural framework itself, since it's not considered and it's not, conducted by things that are, continuous elements, are the joints and the parts that are actually making this type of, total construction is of great importance. The way these things were constructed in the past, it's not only the fact of documenting and of restoring, but it's another thing that is of great importance. It's the fact that in one way or another, we are learning from techniques of the past. So from that point of view, the fact that these people in the past have, faced some problems, and in an evolution way, they have resolved it and come up to a conclusion and come up to a way of constructing things, is something which is an additive knowledge that in one way or another we have to take advantage of it. These terms, because this type of knowledge, and especially in vernacular and traditional construction, which is something, if it's not documented and it's not written, it's something which is in one way or another lost. In Greece, we face it that in many terms with, local construction techniques or local materials or local architectural, identity terms that in one way or another are being lost because they were not documented in a proper way. This mainly affects things that were constructed in the past, where actually we are not, so concerned in terms of, restoration and in terms of, conservation, say, in a broader terms, especially of, modern, what we say, monuments. We had a kind of, great effort that was given in Byzantine, but the monuments or traditional, say, buildings and traditional techniques that are mainly very well connected to the structural framework, it was something that we are not paying in the past so great attention. This type of documentation and this type of, presenting what were either the techniques and what were either the elements and what were either the joints and how was, the whole thing, working together. It's something which is of great importance in terms of first keeping the authenticity of the building and trying to reconstruct it and repair it in the way it was traditionally. And secondly, it's of great importance because by that we are making a documentation and a kind of, say, historic, issue of what were the techniques in the past. Thank you for your attention.
Thank you very much. And we can move on with architect Julia Vobiri.
Όχι, θα διαβάσω.
Vobiri.
Good evening to all the estimate participants. I would like to sincerely thank Mrs. Moropoulou for the invitation to join this panel. In this presentation, I will elaborate on some of my thoughts regarding the preservation of our architectural authenticity in monuments, drawing from recent cases I have encountered during my involvement in their restoration. Architectural authenticity is a concept that on the surface seems self-evident. It refers to the original form and structure of a building before it has undergone any deterioration or intervention. Therefore, one might expect that we should always choose to preserve and highlight this original phase of the monument in every possible way. However, when dealing with a monument, one realizes that the concept of preserving authenticity is far more complex and is influenced by factors such as its age, its use, its historical phases, the available documentation, its structural function, its environment, the presence of frescoes, and others. These factors, along with many others that may vary on a case-by-case basis, define both the perceptions of architectural authenticity and the degree of intervention required for a monument. I will briefly present some examples that I have personally dealt with, as well as a topic that sparked considerable discussion and debate among scholars in the recent past. Restoration of the seaside fort burges at the castle at Methoni, when complete documentation is not feasible. One of the key issues that arises is the degree of certainty we have regarding an intervention. In the case of the fortress, whose structural design was developed of my colleague and today's speaker, Mr. Hatzidakis, despite the detailed efforts made, it was not possible to document the exact form of the intermediate wooden floors of the tower. While some documents were available and the levels of the floors were accurately recorded, it was not feasible to fully document other critical aspects, such as the positions of the stairs, the structural support of the floors, and whether the intermediate floors expanded the entire level. After examining all available data, I decided to propose a solution that would restore the access path to the monument, but this path was essential for modern accessibility and for the function of the monument as an archaeological site. The solution partially restored the levels of the floors while being self-supporting and reversible and constructed from new metal materials. The advantages of this chosen solution were the restoration of access, accurate restoration of floor levels, avoidance of misleading reconstruction, and self-supporting reversible. This approach reflects the principles outlined in Article 9 of the Venice Charter, where the differentiation, reversibility, and restoration up to the point of certainty were emphasized. Balancing monument preservation and modern needs. One of the major challenges in preserving authenticity arises when monuments remain in use. In such cases, the needs of modern users often conflict with the preservation of the architectural authenticity of the monument. In my study of the conservation and energy upgrade of the listed Aegineti Hospital, a significant challenge was finding a balance between the monument's preservation and its contemporary use. The original wooden windows were mainly double-leaf with casement, but many had been replaced with aluminum windows that did not match the original design. These replacements served modern standards for treating mentally ill patients, but altered the monument's authenticity. Similarly, at the Governor's Palace in Rhodos, there are unique windows with artistic and architectural value. However, maintaining these windows created problems with the required energy upgrade. In both cases, the users demanded the replacement of the original windows with materials and design that met modern needs. To address the conflict needs, I propose the following. At Aegineti Hospital, preservation of the original window design at the front building on Vasiliki Sofia Street, while adapting the windows in the other buildings to modern needs. At the Governor's Palace in Rhodos, the windows will particular artistic value will be preserved, while the common design windows will be replaced with new wooden windows that meet energy-efficient specifications, thus retaining the form but not the original material. These examples demonstrate that in some cases, modern needs require flexibility in relation to authenticity. In both cases, the ongoing function of the monument and its more recent dating allowed for greater flexibility in the interventions. Addressing authenticity challenges and restoration techniques. The Temple of Apollo Pythios in Rhodos, an emphatical monument of the island, was restored by the Italians in the early 20th century using methods that are now considered unacceptable. Concrete was used in the trunk and beams of the monument, a practice common at the time, not only by the Italians, but also by Greek restorers. The temple, as it stands today, despite being more didactic in nature, represents a reconstruction of only the northeastern corner. This form has become ingrained in the collective memory. While the Italian restoration contained errors, the intention was to recreate the temple in a way that made it comprehensible in 3 dimensions. The contemporary restoration plan preserves the restoration choices made by the Italians with corrections regarding material use, the protection of original elements, the proper reinstallation of authentic parts, and partial additions to present a more complete form of the monument. The modern approach involves careful use of materials to rectify the mistakes of the past, ensuring the protection and preservation of original components. Due to the deterioration of the original material, some parts of the monument need to be removed and replaced with new similar. To achieve structural stabilization, connections between original and new elements are reinforced with titanium rods for the ancient parts and stainless steel for the new parts. This ensures the monument's integrity. When a monument cannot be fully restored due to the deteriorated state of original materials, structural rehabilitation using new materials is a necessary solution. The aim is to maintain the monument's historical and architectural integrity while ensuring its future stability. This case study illustrates that in the context of monumental restoration, maintaining authenticity often involves a delicate balance between preserving original elements and using modern materials and techniques to ensure the monument's long-term viability. The integration of new materials like titanium and stainless steel, while respecting the historical structure, exemplifies a modern approach to balancing restoration with authenticity. Fourth case, addressing the controversy of relocating archaeological antiquities for the construction of a metro. The relocation of antiquities for the construction of the Venizelos metro station Thessaloniki sparkled significant debate and controversy. While it is clear that moving the antiquities impacted the authenticity of the monument, this was an unavoidable consequence. The challenge remains in balancing the preservation of heritage with the modern needs of urban development. Moving the antiquities undoubtedly harmed the monument's authenticity. The construction of the metro system in Thessaloniki, considering the city's needs today, is seen as a reason of national importance that justified the relocation of the antiquities. Alternative suggestions, such as burying the artifacts, halting the project, or redesigning the construction, will have led to significant traffic management issues for Thessaloniki, making this modern city uninhabitable. While a certain degree of authenticity was sacrificed, the benefits of the project, particularly in terms of public education, urban development, and improved transportation, outweigh the costs in my opinion. The creation of an open-air museum that allows for the public engagement with these ancient artifacts
presents a significant cultural gain for Thessaloniki, making the trade-off between preservation and progress more acceptable. In conclusion, we find that factors such as the preservation of the monument, its historical significance, aging modern needs, and the degree of documentation significantly influence the extent of intervention concerning the preservation of architectural authenticity. As researchers, in my opinion, we must ensure this authenticity without being rigidly fixated on it, disregarding other parameters such as the integration and function of the monument in modern life. After all, throughout the centuries until the 20th century, when the first restoration principles were articulated, monuments were modified and reused based on the needs of the era, creating palimpsests. Therefore, my personal experience has taught me that the best practices for preserving architectural authenticity are in-depth study of the monument, exhaustively documenting, evaluating its place in modern life, researching modern materials and the possibilities they offer, and adhering to international restoration and preservation principles that aim to ensure the monument's protection against any other interests. Thank you.
Λοιπόν, we can surely move with Professor Ioannou from the University of Cyprus.
Right. So, good afternoon, everybody, and thanks for including me in this very interesting discussion. I think it goes without saying that when we are talking about preserving the compatibility, the materiality and the integrity of structures, we also need to think about the environment and the energy upgrading of our structures, at least these days. And why is it so? This is so because, for a start, the construction industry inevitably is a major CO2 emitter, and it is accounting for nearly a staggering 40% of global CO2 emissions. And unfortunately, both Cyprus and Greece, they feature quite highly in terms of direct and total greenhouse gas emissions intensity for the construction industry. And at the same time, at least in Cyprus, we are producing a lot of construction waste, including quarry waste material, and we are not doing a lot to reuse this material, at least for the time being. Now, as for lime, which has been used for the production of mortars and renders since antiquity, either in the form of hydraulic or aerial lime, despite being certainly more environmentally friendly than cement, its production still involves firing of limestone, so there is, of course, CO2 emissions involved during the production of lime. And on top of that, whilst hydraulic lime can set and harden even underwater, the air lime mortars need to go through this very slow carbonation reaction by which portlandite reacts with CO2 to produce calcium carbonate. And this slow reaction hinders the use of these mortars, not only in contemporary architecture, but sometimes also in conservation projects. So here is a challenge. Here is the first question of the day. Can we do something to improve these drawbacks of lime mortars? And one way of addressing this issue is to look into mineral carbonation. And this is a natural way of transforming CO2 into carbonate minerals. It essentially comprises of the chemical reaction of either mafic or ultramafic rock materials containing calcium and or magnesium silicate minerals with CO2 to produce stable carbonate minerals such as calcite and magnesite. So the challenge is whether we can reproduce this mineral carbonation, this natural reaction, using mafic or ultramafic rock additives in lime mortars, and by that doing to enhance both the carbonation reaction of the mortars, but also their sustainability and energy efficiency. The good news is that we can find the raw material suitable for mineral carbonation all over the world, including Cyprus and I believe including Greece as well. In Cyprus, we find these materials in the Troodos-ophiolite region. Of course, what we usually do is we look for the aggregate quarries which are located at the outskirts of the Troodos-ophiolite, and it is from one of these quarries that we obtained one of our samples recently, a quarry waste material with particle size below 75 microns and with the right mineralogy, including minerals which were rich in magnesium, calcium, and iron silicate, iron silicate minerals that were suitable for sequestering CO2. These were minerals like augite and anorthite. So we used this material in producing lime mortars, and we used it in replacement to the lime binders, not as a replacement to the aggregate. And the results were quite interesting and quite promising. We have shown that the mixed designs with the quarry waste additive, or at least in these mixed designs, the intensity of the portlandite peaks was almost diminished. And this was an indication that the additive actually reacted with portlandite to produce calcium carbonate. And this was also confirmed by some tests with phenolphthalein, by which the sample with the quarry waste additive was almost fully carbonated after 90 days, as opposed to the reference sample, which showed only slight evidence of carbonation. And all this in natural conditions without any accelerated carbonation conditions. We also carried some CO2 chemisorption followed by temperature program desorption experiments, which allow fast and accurate measurements of low amounts of CO2 uptake in a great variety of materials. And again, these tests confirm the potential of the mixed design with the quarry waste additive to actually sequester greater amounts of CO2 compared to the reference sample. Practically, this corresponded to an improvement in CO2 uptake in the center of the sample with the waste additive compared with the reference sample of approximately 25 milligrams per gram compared to a mere 2.5 milligrams of CO2 per gram at the surface of the same sample. And if we want to translate this into means of CO2 sequestration, we can say that this is roughly equivalent to an extra about 1 kilogram of CO2 per square meter of render. Supposingly that the thickness of this applied render would be about 2.5 centimeters. And this is again compared to the reference sample. So to sum up, this work, which is pretty much ongoing, has combined the reuse of exploitation of a waste material, a quarry waste material, with the development of a novel environmentally friendly building material with improved properties, which at the same time can also sequester or can also trap CO2 and by thus doing it, it can show its environmental friendliness. So thank you very much.
Okay, thank you very much, and we can now end the first cycle with Mr. Aris Hatzidakis.
So I am not sure if it is a privilege to be the last one or it is rather we are all tired, but I will not show all my presentation here, and I will focus just in one thing that I would like to come out from this panel. It is that we are mature enough to proceed to a regulatory framework that we have left behind 15 years ago. So many things have been evolved since then. We have learned a lot. We had, let's say, proceeded too much on our knowledge on masonry structures or on materials, on analytical methods that we now can, let's say, use. And it is about time that a big synthesis comes out from all this experience we have all these years. And this I feel that this is my main point here, and there are a lot of arguments to, let's say, I don't have to invent anything. I know that every one of you has a lot of experience on these matters, and we've been wondering, as civil engineers, that we are obliged to use numbers. Numbers are not enough in any case. There are cases that you have to base your judgment just on quality aspects and other things that do not come easily to numbers. And as far as it concerns the side of values in monuments, values are not, we do not demand values to be expressed in numbers. So this is a rather easy part, and it is open to any kind of literature. But as it concerns safety computation and the part of civil engineer, things are not so easy. We have to give numbers, and we have to prove that a structure is safe and will remain safe during its lifetime and use. So, although we know that in structures that it is the monument itself is a structure, as Costa said in a while before, we cannot easily touch the structure because it is also an intervention on the form in the same time. So things are not easy, but the most difficult maybe thing is just to, are we sure we know the real stress level that the structure is under? Not even that. Not even that. We know that in the best of cases, we just can predict, let's say, an ultimate load case, but not the actual stress field of the monument. So I will just show what we left behind. This was, I have here some text that are for the moment, let's say, apply to monuments also. I won't come to the guidelines of ISCA-SAC, they are known. We have some, let's say, in some part, Eurocode 8 has to do with structures, part 3, most of that. And then I would like to just to mention the Italian Linee Guida, which is, in my opinion, the most, let's say, elaborated document on monuments. And I'd like just to remind that it is just a guideline. It's not, let's say, a framework and legally binding framework. But safety has legal consequences. For the moment, ugliness does not have. So maybe things are not equal for each part of this, let's say, team that we have to work together, because some of the team are legally responsible for what they're doing, and some others have, let's say, the freedom to invent values or fixed ideas that we have suffered for many years about some fixed ideas. So what I just wanted to say it is that for me that the draft framework that I show on the picture that started to be elaborated 15 years before by a team of engineers and comrades from the Ministry of Culture at the time, and with in the head of the whole this procedure, Professor Tassios has to be again on the table. And besides my, let's say, capacity as former president of European Council of Civil Engineers, I still am, let's say, vice president of OASP, which is the Organization for Anti-Semitic Protection, and we are trying to put on the table again this very serious and nationally important matter. And we hope that this will be done in a professional basis, because you are, let's say, we are used to work on a volunteer basis, but this is not no more enough. So I don't think I have to say anything else. I would like to ask the moderator here and Tonya also to bring this message as a conclusion, at least this demand, because I think that we have to be from now on professionals at this point, and let's say it is just a matter of democracy not to have the civil engineers as the victims of the whole procedure, okay? Thank you so much.
So with this very clear suggestion and conclusion, we can ask Professor Androniki Miltiavou-Fezan to do the reporting for the whole of us.
Thank you, Professor Patsavos. Of course, you may understand it's very difficult to sum up so different matters that we heard in this panel. I will try just to say some words that almost all of us who have used. First of all, it was clear from all the speakers the need for multidisciplinarity. This collaboration, it is clear, but I have to add, being working on these matters for many years, that still it is not so evident that we have it in everyday case studies. Sometimes some monuments are lucky enough to have a multidisciplinary approach. Some others, due to the needs that there exist, the lack of personnel, we are running in order to have at least a civil engineer and an architect. And then if we can have as well some analysis and some chemical engineers, this is very good. But of course, things have changed. This is good. We are in the right way. And we must fight every day to adopt this, I mean, in our everyday life, not only in the papers, in the congresses. Multidisciplinarity, it's an everyday effort. The other point I would like to raise is the famous value of authenticity. Very, very difficult word regarding its meaning. What does this mean? So here as well, we must not stick that authenticity is the material itself, because sometimes we are obliged to touch the material. This is for all of us. We know that we touch the material, we take some material out, and then we say that the intervention is reversible. That it is not true. That is why, as I told in the beginning, we have a tendency, at least in the ISCAR committee, to try to introduce a more clear work, a more honest work, removability. I intervene with a certain intervention and then I can remove it without saying that this is completely reversible. So authenticity as well, as a lot of speakers have raised, and especially for modern structures, it's a big discussion. What is authentic? It is the material or the form or the functionality. So I think that this can be a whole Congress discussing about this matter, so I don't want to go further, but probably it is better sometimes to speak with more technical words than authenticity. So when we use compatibility, when you use durability, when you use other values, this may be more clear because you can define them in technical terms. So then, I think we heard a lot about new materials. It was very good to have an information about new European programs, about the lime, which is really a material coming from the past but having a long future, and this is very, very important. We heard many information about the future of these materials, but as well the fighting about all these coating material, the polymers, how we can make them more useful. So this was very good, and it is normal in such congresses to hear those approaches. But in all cases, I think, and I'm coming now to our colleagues that are architects and civil engineers, but as well in the material scientists, a word that has to be underlined, it is optimization. In all cases, whatever we work with materials, we have to optimize various parameters and their impact, and in many cases, this impact is not only quantified with technical terms, but as well with social, ethical, aesthetic terms. That is why we need optimization, because we cannot put in a balance things that they are not similar. So we need optimization and multidisciplinary team to optimize this approach. So I think that, again, this is an effort that has started for years from all of us that will work in the domain, from ISCAR and then the Italian colleagues and our regulatory document. This is the word, optimization. And because this is the only way in order to arrive to select finally an intervention or a material based on its capacities from the technical point of view, and from the other point of view on its impact on these values, which are not really measured with technical terms. And coming to this, yes, I hope, dear Aris, that we shall come back and have again the regulatory document on the table. All of you, you know that I have worked for years about this matter with Professor Tassios and other colleagues. And it is very important for our country because you have earthquakes and the intervention of the civil engineers. They have a big impact on the materials and all the integrity of the monuments. I don't know what I left. And of course, I would like to say that this optimization has as well all the phases, the anamnesis and the documentation, as Professor Karadima says, the importance of the documentation of the structural systems. It has as well the phases of diagnosis, which means all the use of entities that some colleagues have how to say, have referred to and their importance, but it has not only the entities, but as well their calibration. So we need documentation in order to calibrate. And then the therapy, of course, where we have all the interventions, the materials proposed, and the new era of nanomaterials, of how to be environmentally friendly. And finally, the control, which is mean that whatever we're doing in the laboratory or in situ, we need to control its efficiency. So we need all of us to have these phases: anamnesis, diagnosis, therapy, and control, whatever our work is in the laboratory or in situ. I tried to sum up. I don't know if I managed. Thank you very much for your attention.